This video is for those of you who are studying for the pre-calculus final exam. Now, it really doesn't contain many trig questions aside from law of sines and law of cosines and a few triangle problems. But if your exam does contain trig, I do have a separate video dedicated for that. If you go to YouTube and do a search, type in trigonometry final exam review, organic chemistry tutor, it should come up. If not, you can check the description section of this video and you should see a link there. I'm going to post a link to that trig final exam review in the description section of this video. So take a look at that when you get a chance. You'll probably see some other links there as well. Now, for these questions, I recommend that you pause the video and try to work on it. And then once you finish working on the problem, play the video to see if you have the correct solution. So let's begin with number 1. What is the value of x in the equation shown below? So how do we solve this exponential equation? The first thing we need to do is convert the bases. We need to make sure the bases are the same. 8 and 16, they both have a common base of 2. 8 is basically 2 to the third power. You need to multiply 3 2's to get to 8. And 16, we can replace that to, or replace it with 2 to the fourth power. So now, what do we do when we have an exponent raised to another exponent? In this case, we need to multiply. So let's multiply 3 by 3x plus 5. 3 times 3x is 9x. And then 3 times 5 is 15. Now let's distribute the 4. So 4 times 2x is 8x. 4 times negative 3 is negative 12. So now that the bases are the same, what we can do is set the exponents equal. I'm not sure what just happened here. But we could set the exponents equal to each other. So now we could say that 9x plus 15 is equal to 8x minus 12. Now, let's subtract both sides by 8x, and at the same time, we can subtract both sides by 15. So these will cancel. On the left side, we have 9x minus 8x, which is 1x. On the right side, negative 12 minus 15, that's a negative 27. So we can see that the answer is answer choice A, x is equal to negative 27. Number 2, if f of x is equal to 8 over x minus 3, then what is f of negative 1 of 4? So basically, what is the inverse function evaluated at 4? How do we find the inverse function of f? Well, let's begin. The first thing you want to do is replace f of x with y. So we have y is equal to 8 over x minus 3. Now, to get the inverse function, the next step is to switch x and y. So we're going to have x is equal to 8 over y minus 3. Now, we need to solve for the y variable. So let's put this over 1 and cross multiply. So we're going to have 8 is equal to x times y minus 3. Our next step is to divide both sides by x. So we're going to have 8 over x is equal to y minus 3. Now, let's add 3 to both sides. So we're going to have 8 over x plus 3 is equal to y. So once you solve for y, this is your inverse function. So replace y with f of negative 1. So we could say that f of negative 1x, or the inverse function of x, is 8 over x plus 3. Now, all we need to do at this point is plug in 4. So this is going to be 8 over 4 plus 3. 8 divided by 4 is 2. 2 plus 3 is 5. So f of negative 1 of 4 is equal to 5, which means that answer choice D is the right answer. Now, if you want to check your work mentally, here's what you can do. If f of negative 1 of 4 is 5, then the original function f of 5 has to be 4 because we switched x and y. So let's plug in 5 into this function and let's make sure that we get 4. So first, let me just make some space here. Get rid of that. So f of 5 is going to be 8 over 5 minus 3. Now 5 minus 3 is 2. 8 divided by 2 is 4. So we can see that indeed f of 5 is equal to 4. So another way in which we could have gotten the same answer is we could have replaced f of x with 4 and solve for x. In that case, x would be 5, and that will be our answer. So we really didn't have to find the inverse function, but it wasn't wrong to do that. So there was two ways in which we can actually solve this problem. Number 3, evaluate the logarithmic expression shown below. So what is log base 27 of 1 over 3? Now there's multiple ways in which you can get the answer, but let's talk about how to do it mentally. First, what is log base 2 of 8? How many 2's do you need to multiply to get to 8? You need to multiply 3 2's to get to 8. So 2 to the third power is 8. So it turns out that log base 2 of 8 is 3. What about log base, let's say 4 of 16? 4 raised to the what power is 16? How many 4's do you have to multiply to get to 16? This is going to be 2. What about log base 5 of 125? How many 5's do you need to multiply to get to 125? This is going to be 3. Now, if log base 2 of 8 is 3, what is log base 2 of 1 over 8? Well, we know that 2 to the third power is 8. So 2 to the negative third power is 1 over 8. So if you have a fraction here, the answer becomes negative. Now, what if we were to reverse 8 and 2? If log base 2 of 8 is 3, what is log base 8 of 2? So 8 raised to the what power is 2. We know that the cube root of 8 is 2. So this is 8 to the 1/3. So if the larger number is here, this becomes a fraction. Instead of being 3 or 3 over 1, it's now 1 over 3. Now what about log base 8 of 1/2? So if we have a fraction here, this is going to be negative. So instead of 1 over 3, it's going to be negative 1 over 3. Now I'm giving you these examples so you could see how to do this mentally in your head. But for those of you who prefer to do it the written way, I'll show you what to do. In the meantime, go ahead and answer these questions. Evaluate log base 3 of 27, log base 3 of 1 over 27, and then base 27 of 3. Now, 3 to the what power is 27? How many 3's do you have to multiply to get to 27? You need 3 3's to get to 27. Now, if we change it from 27 to 1 over 27, the 3 will become negative 3. And if we reverse 3 and 27, this 3 becomes positive 1 over 3. We just simply flip it under 1. Now, if we compare this with this one, if we change 3 to 1 over 3, the positive 1/3 will now become negative 1/3. So the answer is answer choice B. But here's what you can do if you don't want to do it mentally. Set this whole thing equal to x, and then convert the logarithmic expression into an exponential expression. Let me give you an example. Log base a of b is equal to c. A raised to the c is equal to b. So that's the process that you could use to convert it into an exponential expression. So we're going to say that 27 raised to the x is equal to 1 over 3. Now, let's solve for x by getting a common base. Now, we could replace 27 with 3 to the third power. And 1 over 3 is basically 3 to the negative 1. Now, 3 to the third raised to the x, we need to multiply these two exponents. We always do that whenever we raise one exponent to another. So we have 3 to the 3x is equal to 3 to the negative 1. Now that we have the same bases, the exponents must be equal to each other. So we could say that 3x is equal to negative 1. Dividing both sides by 3, we get that x is negative 1 over 3. So that's how you can show your work to get the answer. The other method involves the use of a calculator. You need to use the change of base formula. So let me give you the formula. Log base a of b is equal to log b divided by log a. Now the new base, it could be anything, so we're going to call it c. It could be 5, it could be 7, it could be 24, any number you want. But with a calculator, all you need to do is type in log 1 over 3 divided by log 27. The calculator will automatically use base 10 for the logs. But it doesn't matter what the base is, the answer will still be the same. So let's go ahead and type that in. And this is going to be negative 1 over 3, or your calculator might say negative 0.3333 repeated. So answer choice B is the right answer. Number 4. Using the piecewise function below, what is the sum of f of negative 2 and f of 3? By the way, if you don't see a topic in this video that you're looking for, I recommend that you search out my Precalculus playlist. So if you go to YouTube, type in Precalculus playlist, organic chemistry tutor, it should come up, and pick the new one. So chances are you'll find that topic that you're looking for in that playlist if you don't see it in this video. So let's continue with this problem. So we need to determine the sum of these two function values. Let's start with f of negative 2. Which portion of the piecewise function should we use to find the value of f of negative 2? Should we use the top one or the bottom one? Negative 2, is that less than 2 or greater than 2? Since negative 2 falls in this category, we need to use the top portion of the piecewise function. So it's going to be negative 2 squared minus 5 times negative 2 plus 3. So negative 2 squared, that's positive 4. Negative 5 times negative 2 is positive 10. So 4 plus 10 plus 3 is 17. Now, let's evaluate f of 3. 3 is greater than 2, so we need to use this second portion of the piecewise function. So it's going to be 4 times 3 minus 7. 4 times 3 is 12. 12 minus 7 is 5. So now, we can find a sum of f of negative 2 and f of 3. So it's going to be 17 plus 5, which is 22. So answer choice D is the answer. Number 5. What is the value of x in the logarithmic equation shown below? So what we need to do, like we did before, is we need to convert this logarithmic equation into an exponential equation. 3 to the 4th power will equal what's inside. As you recall, when we had log a of b is equal to c, we said that a raised to the c is equal to b. So we're going to follow that same process here. So 3 to the 4th power is 8x plus 1. Now what is 3 to the 4th power? So if we have 4 3's, what is that equal to? Well, we know that 3 times 3 is 9. And 9 times 9 is 81. So 3 to the 4th power is 81. Now let's subtract both sides by 1. 81 minus 1 is 80. Next, let's divide both sides by 8. So 80 divided by 8 is 10. Thus, x is equal to 10. So the correct answer is answer choice C. Number 6. Karen invests $15,000 into an account that grows compounded continuously at an annual rate of 9.5%. How many years will it take for her money to double? So what formula do we need in this problem? Perhaps you've seen this equation. A is equal to PERT, PE raised to the RT. P is basically her principal, the amount that she's going to put into the account. A is going to be the account value after some time period has elapsed. E is basically a number. It's the inverse of the natural log function. R is the annual interest rate, and T is the time in years. So her investment, the principal, is $15,000. We want to see how long it takes, we want to see how long it takes for her money to double. So that is, her future account value will be $30,000. R is the interest rate as a decimal. So we need to convert the percentage into a decimal. We can do this by dividing 9.5 by 100. And so R is going to be 0.095. So you can move the decimal point 2 units to the left. Since we're trying to determine how many years it's going to take for our money to double, our goal is to solve for the variable t. So let's begin by dividing both sides by 15,000. 30,000 divided by 15,000, well, this becomes 30 divided by 15. That's 2. So we have 2 is equal to e raised to the 0.095 times t. So how do we solve for a variable in the exponent position? How do we do that? The only way to do that is to take the logarithm of both sides, or the natural log of both sides. I prefer to use the natural log because we have the base e. It's important to know that ln e is 1. So use natural logs here. So we're going to have ln 2 is equal to ln e raised to the 0.095 t. Now, a property of logs allows us to take the exponent and move it to the front. For instance, ln a to the second power is equal to 2 ln a. We can take the 2 and move it to the front. So we're going to take this whole thing, move it to the front here. So it's going to be 0.095t times ln e. And ln e is 1, so that's going to disappear. So let's rewrite what we have on the top of the page. So to isolate t, what we need to do next is we need to divide both sides by 0.095. So the time it takes to double for a problem where it grows compounding continuously is simply the natural log of 2 divided by the annual interest rate as a decimal, 0.095. And so the answer I get is 7.296 with some other numbers. So we can round that to 7.3. So that's how long it's going to take for Karen's investment to double at this interest rate. Number 7. Susan deposits $30,000 into a mutual fund that averages an annual interest rate of 9% compounded monthly. At this growth rate, what will be the value in the account after 40 years if she makes no withdrawals? So this is basically a free response problem. And you need to know the formula to use. So in the last example, we use A equals PERT whenever the growth rate is compounding continuously. But if it's not compounding continuously, this is the formula that you need to use. Now, P is the principal. We know that it's 30,000. That's how much she invests into this mutual fund. R is the annual interest rate, which is 9%, but we need to divide that by 100, so we're going to plug in 0.09 for R. N is the number of times that the account is basically credited with interest in a year. So it's compounded monthly. So how many months are in a year? We know that there's 12 months in a year, so N is 12. T is the total number of years that the money is kept in the account. And so she's going to keep it for 40 years. So T is 40. So now let's plug in what we know. So this is going to be 30,000 times 1 plus 0.09 divided by 12 raised to the 12 times 40. So basically, you can type it in exactly the way you see it into your calculating device. So here's the answer that I got. In 40 years, her account value should be $1,083,297.06. So this example really illustrates the power of compounding when you're saving for the long term. Number 8. What is the sum of all the zeros in the polynomial function shown below? So how can we find the answer to this problem? Now, we can't really factor this polynomial right now. So what we need to do is list the possible zeros that we can get in this polynomial, find one that works, and then use synthetic division to find the others. So the first thing we need to do is write out the possible factors of the last number, 24. So possible factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. And then we need to divide these by the possible factors of the leading coefficient, which is just 1. So we have a lot of numbers to choose from. So it's best to start with the smaller numbers, 1 and 2. So what we want to do is we want to plug in a number and see if it's going to equal 0. So let's start with f of 1. F of 1 is 1 to the third power minus 3 times 1 squared minus 10 times 1 plus 24. To save time, it's best to just type this in. And so I got 12 for this, so this doesn't equal 0. So x equal 1 is not a 0. Let's try negative 1. And let's type it in as well. So I got 30 for this. Now let's move on to the next one. Let's try 2. So this is going to be 2 to the third minus 3 times 2 squared minus 10 times 2 plus 24. So I got a 0. So the first 0 is x is equal to 2. So let's highlight this answer. And now let's use synthetic division to get the other ones. So what I'm going to do is I'm going to put the 2 here. And then I'm going to write the coefficients of this polynomial function here. It's 1, negative 3, negative 10, and 24. So first we're going to bring down the 1. And then we're going to multiply. 2 times 1 is 2. And then we're going to add. Negative 3 plus 2 is negative 1. And then multiply. 2 times negative 1 is negative 2. And then add. So those two numbers will add to negative 12. And then multiply. 2 times negative 12 is negative 24. And then they add to 0. So when you divide x cubed by x, you're going to get x squared. This is going to be 1x squared minus 1x minus 12. So now what we could do, let me just get rid of that circle on top, is we can now factor this expression. So it's equal to, since this is x is equal to 2, as a factor, we're going to write it as x minus 2. And then it's going to be times what we see here. X squared minus x minus 12. So if you were to multiply this binomial by this trinomial, you should get this polynomial that we started with in the beginning. Now to find the other zeros, one thing we need to do is set this function equal to 0. So if you set x minus 2 equal to 0, you'll get this answer, x equals 2. But now, how can we factor this trinomial? So what two numbers multiply to the constant term negative 12, but add to the middle coefficient negative 1? Negative 12 is basically 4 times negative 3. But these two numbers add up to positive 1. If we reverse the signs, these two will add up to negative 1. So we can factor it as x minus 4 times x plus 3. So now we can see all the zeros that we have. If you set x minus 2 equal to 0, you'll get x is equal to 2. If you set x minus 4 equal to 0 and solve for x, you'll get x is equal to 4. And for this one, negative 3. Now, our goal is to find the sum of all the zeros. So what is the sum of 2, 4, and negative 3? 2 plus 4 is 6. 6 plus negative 3 is positive 3. So this is the final answer. Answer choice C. Number 9. What is the domain of the function shown below? So we have f of x is equal to the square root of 5 minus x. So which is the answer? Is it 5 to infinity, negative 5 to infinity, negative infinity to 5, or something else? Now it's important to understand that we can't have a negative number inside a square root. The square root of negative 4 will not give us a real number. It will give us an imaginary number. We know the square root of 4 is 2. The square root of negative 4 is basically 2i. Keep in mind, the imaginary number I is the square root of negative 1. So for this radical function, we can't have any negative numbers inside the square root. So inside the square root, 5 minus x, this has to be greater than or equal to 0. Now for those of you who may have trouble finding the domain of a function, like this problem, I have a video on YouTube that is just dedicated to doing that. If you type in how to find the domain of any function, organic chemistry tutor, it should come up. But now let's get back to this problem. Let's begin by subtracting both sides by 5. So we're going to have negative x is greater than or equal to negative 5. Next, let's divide both sides by negative 1. Now, when solving with inequalities, whenever you multiply or divide both sides by a negative number, the direction of the inequality changes. Negative 5 divided by negative 1 is positive 5. So we get that x is less than or equal to 5. Now, which one of these answer choices corresponds to this inequality? If you're not sure, here's what you can do to help. Yourself get the answer. Draw a number line. So let's say this is 0, this is 5. And then plot the solution on a number line. So x is less than or equal to 5. Do we need an open circle or a closed circle at 5? What would you say? Because of the underline, it includes 5. So we need a closed circle. And because it's also less than 5, we need to shade to the left. If it was greater than 5, we would shade to the right. Now all the way to the right we have positive infinity, and all the way to the left we have negative infinity. So going from left to right, the shaded region starts at negative infinity and it ends at 5. So the answer is going to be from negative infinity to 5. Now, what we need to determine is, are we going to use parentheses or brackets? You should always put a parenthesis next to an infinity symbol. Now, whenever you have a closed circle, you should always use a bracket. For open circles, use a parenthesis. So the answer is going to be negative infinity to 5. So C is the right answer. Now let's check to see if the answer makes sense. So looking at our solution, x cannot be greater than 5. So what's going to happen if we plug in 6 into this expression? So this would be the square root of 5 minus 6, and 5 minus 6 is negative 1. So this will give us an imaginary number, not a real number. So that's why x equals 6 is not in the domain. But if we pick a number less than 5, like 4, then it works. 5 minus 4 is 1. The square root of 1 is a real number, 1. And so you could check your answer to see if it makes sense. Your answer should include all the possible values of x that can go into this formula or into that function. Number 10. Write the domain of the function shown below using interval notation. Now what you need to understand is that when dealing with a rational function, basically a function in a fraction, the function will be undefined if there is a 0 in the denominator. And so the x values that lead to that situation has to be removed from the domain of the function. So basically, the denominator, 6x squared plus x minus 15, cannot equal 0. So how do we find the x values that will cause it to be 0? Well, we need to factor this trinomial. Earlier in the video, we factored a trinomial where the leading coefficient is 1. This time it's not 1. So there's going to be a little bit more work that we have to do here. What we need to do is multiply the leading coefficient by the constant term. And so 6 times negative 15, that's going to be negative 90. Now we need to find two numbers that multiply to negative 90 but add to 1. So what are some numbers that multiply to 90? So we have 3 and negative 30. We have 5 and negative 18. If you divide negative 90 by 5, you get negative 18. There's 6 and negative 15. There's 9 and negative 10. But notice that these two add up to negative 1. So if we reverse it, these two add up to positive 1. So what we're going to do now is we are going to replace the middle term, positive x, with negative 9x plus 10x. Because these two, they will simplify to x. So the value of the expression does not change. So now let's get rid of this. At this point, we need to do something called factor by grouping. Notice that 6 to 9 has the same ratio as 10 to 15. If you divide 9 by 6, you get 3 over 2. If you divide 15 by 10, you get 3 over 2. So if you have 4 terms where the first two and the last two have the same ratio, you can factor by grouping. So what we're going to do is we're going to take out the GCF in the first two terms. The greatest common factor between 6x squared and 9x is 3x. 6x squared divided by 3x is 2x. Negative 9x divided by 3x is basically negative 3. Now, what is the GCF between the last two terms? The GCF is going to be positive 5. 10x divided by 5 is 2x. Negative 15 divided by 5 is negative 3. Notice that these two terms are the same. So that tells us that we're on the right track. So what we're going to do now is factor out the GCF within these two terms. And so we can clearly see that the greatest common factor is 2x minus 3. So this divided by 2x minus 3 will give us 3x. And if we take out 2x minus 3 from the second term, we're left with positive 5. So these are the two factors that we have. Now let's separate each factor. Each of them must not equal 0. So at this point, we can get rid of this. So let's add 3 to both sides. So I have 2x cannot equal 3. And then if we divide by 2, we get that x cannot equal positive 3 over 2. So that's the first one. Now for the second one, we need to subtract both sides by 5. So we'll get that 3x cannot equal negative 5. And then divide by 3. So x cannot be negative 5 over 3. So now that we know the x values that lead to the function being undefined, how can we take this information and write the domain using interval notation? What I recommend is the number line. So let's put 0 first, and let's put the other x values that we have. Negative 5 over 3 is to the left of 0, and positive 3 over 2 is to the right of it. And don't forget to put positive infinity on the right, negative infinity on the left. Now, x cannot equal 3 over 2. So we need an open circle at 3 over 2. And it also cannot equal negative 5 over 3. So we need an open circle at that point, not a closed circle. Now, x can be anything else. It could be 5, it could be negative 8, it can be 2, it could be 1 over 3, anything else. So we need to shade everything except negative 5 over 3 and 3 over 2. Now I'm going to use different colors for this, and you'll see why. So there's 3 sections to our answer. So here's the first section. As we read the basically number line from left to right, that's going to give us the domain. So it's from negative infinity to negative 5 over 3. Now because we have an open circle, we're going to put a parenthesis next to negative 5 over 3. So that's the first section, highlighted in blue. Now the second part, which we're going to highlight it in red, it starts from negative 5 over 3 and ends at 3 over 2. Now the third part, which starts in green, it begins at 3 over 2 and it ends at infinity. So that's how you can write the domain for this particular rational function. Number 11. Which of the following choices represents a solution to the logarithmic equation shown below? Is it A, B, C, D, or E? So how can we solve this particular logarithmic equation? Well, you need to be familiar with some of the properties of logs, particularly this one. Log A plus log B is equal to log AB. So you can take two log expressions, combine it into a single log by multiplying A and B. So that's what we need to do in this example. we need to condense the two logarithmic expressions into a single log by multiplying x plus 5 with x plus 1. Now let's go ahead and FOIL that expression. So we have x times x, which is x squared. And then we have 1x, which we can add that with 5x, giving us 6x. And then 5 times 1 is 5. Now we have a single log expression equal to a number. So at this point, we want to change the equation from its logarithmic form into its exponential form. Starting with the base, we have 2 raised to the 5th power is equal to the stuff inside. Now, what is 2 to the 5th power? If you multiply 5 2's together, what will you get? 2 to the 5th power is 32. Now, our next step is to subtract 32 from both sides. So we're going to put a 0 on the right side. 5 minus 32 will give us a negative 27. So now we have a trinomial where the leading coefficient is 1. So we need to factor this expression. What two numbers multiplies to the constant term negative 27 but add to the middle coefficient 6? So this is going to be 9 and 3, particularly positive 9 and negative 3. 9 plus negative 3 adds up to 6, but they multiply to negative 27. So this is going to be x plus 9 and x minus 3. Now, using the zero product property, if we set x plus 9 equal to 0 and solve for x, we're going to get that x is equal to negative 9. If we do the same with the other factor, x minus 3, we'll see that x is equal to positive 3. Now we have two answers. This corresponds to answer choice A, and this corresponds to answer choice D. Are both answers correct, or is one of them an extraneous solution? What would you say? Now, what you need to keep in mind is that logarithmic functions have a restricted domain. Within the inside of a log function, it cannot equal 0 and it cannot be negative. So, if we were to replace x with negative 9, the first part will be negative 9 plus 5, which is basically log base 2 of negative 4. So this is not part of the domain of logs. You can't have a negative number inside of it. So this is an extraneous solution. So the correct answer is 3, because if you plug in 3 into x plus 5, you're going to get a positive number. If you plug it in into x plus 1, you will also get a positive number. And so this is the answer. And if you want to check it, it's going to equal 5. So here we're going to have log base 2, 3 plus 5, and then log base 2, 3 plus 1. Let's make sure that it's equal to 5. So 3 plus 5 is 8, and 3 plus 1 is 4. Now log base 2 of 8, how many 2's do we have to multiply to get to 8? That requires 3 2's. How many 2's do we need to multiply to get to 4? That's 2 4's. So 3 plus 2 is 5. We can see that the solution is correct. So D is the right answer choice. Number 12. If f of x is equal to x squared minus 4x plus 3, and g of x is 3x plus 5, then what is the value of f of g of negative 1? So how do we evaluate a composite function? Well, it's best to take this one step at a time. First, let's find the value of g of negative 1. So we're going to use this. G is 3x plus 5. Let's replace x with negative 1. So this is negative 3 plus 5, which is positive 2. So now we can focus on evaluating f of g of negative 1, because we know that g of negative 1 is 2. So let's replace it with 2. So now we need to plug in 2 into f. So f of 2 is going to be 2 squared minus 4 times 2 plus 3. 2 squared is 4. 4 times 2 is 8. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. So this is the final answer, which correlates to answer choice B. So that is the value of the composite function f of g of x when x is 1. Number 13, which of the following graphs shown below does not represent a function? So what do you think we need to do here? How can we tell if a graph represents a function or not? What type of test do we need to use? We need to use something called the vertical line test. If the graph touches the vertical line more than once, it is not a function. So looking at answer choice A, we can see that the red curve touches the graph only once. So this is a function. Answer choice B, it touches it only once. So that's a function. For D, it touches it once too. But for C, it touches it at multiple points. So one x value has at least, in this case where that line is, 3 y values, which is not a function. Every x value should only correspond to one y value in a function. So C is the answer. This does not represent a function. Now, it's important for you to know the parent functions of certain graphs. For instance, for answer choice A, this is the parent function x squared. And for B, this is y is equal to x cubed. And D represents the parent function, the square root of x. So just keep that in mind. 14. Graph the absolute value function shown below. Write the domain and range using interval notation. So let's use transformations to do so. The absolute value of x, the parent function, it looks like this. It's basically a graph with a V shape. Now, let's say if we add 3 to it. This will shift the graph 3 units up. So it would start at positive 3. Now what about putting a plus 2 inside the absolute value symbol? What effect will that have on a graph? So instead of having a vertical shift, what we're going to have is a horizontal shift. But it's going to be not to the right, but to the left 2 units. Because if you set x plus 2 equal to 0, x will be negative 2. So that's a horizontal shift left 2 units. Now what about, let's say, if we put a negative sign in front of the absolute value symbol? In this case, this is going to be a reflection, but over the x-axis. So it's going to open downward. And what we have is a combination of these 3 things in this example. We have the negative sign in front, plus 2 on the inside of the absolute value symbol, and plus 3 outside of everything. So the graph is going to shift up 3 units, left 2, and it's going to reflect over the x-axis. So let's make a bigger graph. What we're going to do first is we're going to move the original point. The original point started at the origin, but that point is going to move 2 units to the left, and then it's going to move up 3 units. So it's going to be at negative 2, 3. And the graph is going to open downward. Now the slope, the number in front of x, is a 1. So as we travel 1 unit to, let's say, the left, we need to go down 1. So that's going to give us the point negative 3, 2. And then as we go 1 to the left, down 1. So the next one is going to be negative 4, 1. And at this point, we can draw a straight line. Now the right side is going to be the same. As we go 1 unit to the right, we need to go down 1. 1 to the right, down 1, and so forth. So that's basically a rough sketch of this particular absolute value function. So that's how you can graph it using transformations. Now, let's focus on writing the domain and range using interval notation. The domain has to do with the x values. So notice that the blue line goes all the way to the left due to the arrow. So it's going to go from negative infinity to the left side, from the left side, all the way to the right side to positive infinity. So there's no restrictions on the value of x in this function. X could be anything. Now what about the range? What's the range in this example? When analyzing the domain, because you're dealing with the x values, you need to analyze the graph starting from the left and going to the right. When analyzing the range, you're analyzing the y values. So you need to analyze the graph starting from the bottom, going to the top. So the lowest y value is negative infinity. This line will keep going down. The highest y value is here, positive 3. There's no blue line above y equals 3. It stops there. So the range, the lowest y value, starts from negative infinity to the highest y value, 3. And always put a parenthesis next to an infinity symbol. Now, because 3 is included, we're going to use a bracket. Because if you plug in negative 2, you'll get 3 for y. And so that's how you can write the domain and range from a graph. Number 15, graph the exponential function shown below. Write the domain and range using interval notation, and then identify any asymptotes. So, for exponential functions, there's a certain way in which I like to graph it. Now there's other ways which can still lead you to the same answer. But the way I like to do it's a very simple way. Now the first thing is identifying the asymptote. Exponential functions have a horizontal asymptote. And you can see it right here. In this case, it's y is equal to 1. If you don't see a number here, it's y equals 0. So that's the first thing that I'm going to plot. So I'm going to put that in blue. So this is our horizontal asymptote at y equals 1. Now the next thing that I like to do is I like to take the exponent and set it equal to two numbers. I'm going to set it equal to 0 and I'm going to set it equal to 1. And then using those x values, I'm going to make a table. If you set x plus 3 equal to 0 and solve for x, x will be negative 3. If you solve the second one, 1 minus 3 is negative 2. Now what we need to do is plug in these values to get the y value. So let's start with negative 3. Negative 3 plus negative 3, negative 3 plus 3 rather, is 0. Anything raised to 0 power is 1. And 1 plus 1 is 2. Now, let's replace x with negative 2. Negative 2 plus 3 is 1. 2 to the first power is 2. 2 plus 1 is 3. So now what you want to do is you want to plot those 2 points on the graph. So the first one is negative 3, 2, which is here. And the second one is negative 2, 3. And then what you need to do is start the graph from the horizontal asymptote and follow the 2 points. And that's how you can draw a rough sketch of an exponential function. It's one of the most efficient ways to do so. So now we can focus on writing the domain and range. So starting with the domain, we need to analyze the function from left to right. So it starts all the way from the left, which is negative infinity, and as the function goes up, it will continue to go to the right. So it will extend towards positive infinity, which means x can be anything. You can plug in any value for x. So it's all real numbers for the domain. It ranges from negative infinity to infinity. Now let's focus on the range. So we need to analyze the graph from the bottom to the top. So the lowest y value is the horizontal asymptote, which is 1. The highest is infinity. So it goes from 1 to infinity. But notice that I do not have a bracket at 1 because the graph will never touch 1. It will always, initially it starts just above 1, but never exactly 1. There's no x value that you can plug in that will make y exactly equal to 1. You can get close to 1, but it's not going to touch 1. So we need a parenthesis and not a bracket at 1. So this is the domain and range for this particular function.